everyone. So till last class I have finished explaining all the concepts of Amines chapter. Now in today's class I'm going to solve some of the questions so that it will be easier for you when you try to solve all the questions on your own. The first question is from the basic character of amines under the chemical properties. The question says, arrange the following compounds in increasing order of their basicity. Increasing order means you have to write it from low to high. So in this case, by looking at the compounds given, you need to identify which of the amine has electron donating group, which of the amine has electron withdrawing group. As we already learned that electron donating group will increase the basicity, whereas the electron withdrawing group will decrease the basicity. So in this case, the first one, C2H5 acts as an electron donating group and C6H5 refers to a benzene ring. So this acts as an electron withdrawing group which decreases the basicity. And in the third one, there are two electron donating groups present. And in the last one, there's only one electron withdrawing group. So when you compare the effect of electron donating and electron withdrawing effect, you will see that the compound with the most electron withdrawing effect will have the least basicity. So therefore, aniline in this case, this will have the least basicity. You can also write it in the form of a benzene ring instead of C6H5 and then your NH2. Now this will have the least basicity, then followed by this compound, NH and CH3, because this has an electron withdrawing group but it also has an electron donating group. So therefore this will be more basic compared to this compound, and then it will be followed by the compound with one electron donating group, so C2H5 NH2, and this will be the most basic because it has two electron donating groups present, C2H5 twice NH. So that's how you arrange the compounds on the basis of their basicity, depending upon whether it has electron donating or electron withdrawing group. The next one is again, you have a aniline compound here, and then again it carries a benzene ring which acts as an electron withdrawing group, but it also carries two electron donating group. And in the third one, two electron donating groups, and this one carries one electron donating groups. All alkyl groups are electron donating groups. So in this case, this will be the again least basic, C6H5 NH2, followed by this compound, C6H5 and CH3 twice. Then when you compare the basicity of this two, because of two electron donating groups, this will be the most basic, and that will be less basic compared to this one, NH2, and then C2H5 twice NH. Okay. Now in the third one, aniline, para-nitroaniline and tetratoletane. First you need to write down the structure for this. Now para-nitro indicates you have a nitro on the fourth carbon atom. So this is my fourth carbon atom, I have a nitro group, and first carbon will have the NH2, para-nitro aniline, and this one is benzene with NH2. Okay, and this has a CH3 on the fourth carbon atom, para-toluene. Para-toluene refers to the fourth carbon with CH3, and then NH2 on the first carbon. Okay, so if you look at the electron donating and the electron withdrawing effect, you can see that this has got one benzene ring which acts as an electron withdrawing group, whereas in this case you have two electron withdrawing groups. NO2 is also an electron withdrawing group, benzene ring is also an electron withdrawing group, whereas in this case there's an electron withdrawing group present, but it also has an electron donating group, that is your CH3 group. So when you compare the basicity, it is seen that this will have the least basic character because of 2 electron withdrawing group present. Therefore, para-nitroaniline followed by aniline, and the most basic is para-toluene. Okay, so this type of questions are being asked. They will give you a set of compounds and you have to arrange in either increasing order or decreasing order. So that's about the first question. The second question is arrange in increasing order of boiling point. So whenever you are comparing the boiling temperature, you need to look at the possibility of formation of intermolecular hydrogen bond. So whenever there is more intermolecular hydrogen bond formation, the boiling point will be always high. So in this case, alcohol, it is ethanol, and in this case it is a secondary amine, and this is a primary amine. So in the case of alcohol, the hydrogen bond formation is very strong compared to the amine compounds. Therefore, this will have the highest boiling point. Now, when you compare the possibility of hydrogen bond formation, intermolecular hydrogen bond formation among these two, in this case, there is 2 hydrogen atoms available for hydrogen bond formation, whereas in this case, there's only 1 hydrogen atom available for hydrogen bond. So therefore, this will be the compound with the highest boiling point, followed by this and then this primary amine. So when I write it in the increasing order, again from low to high, CH3 twice NH will have the lowest boiling point, followed by C2H5 NH2, and then your alcohol C2H5OH. That's all. Now the third question is arrange in increasing order of solubility in water. Solubility depends upon the ability to form hydrogen bond with the water molecules. It also depends upon the carbon chain which is attached to the nitrogen atom. If the carbon chain is more, the hydrophobic part is more, as we have already discussed, it becomes less soluble in water. So this one is aniline, benzene with NH2. Now if I write the structure for this, benzene and NH2, aniline, whereas in this case you have got 2 ethyl groups and 1 hydrogen atom, whereas in this case it is only 1 ethyl group and 2 hydrogen atoms. So when you compare the bulkiness of the groups which is attached to the nitrogen atom, this nitrogen has only 1 ethyl group and 2 hydrogen atoms available for hydrogen bonding with the water molecules. Therefore, this will be most soluble in water, followed by this compound, and the least soluble will be this because it has a large hydrophobic part which makes it insoluble in water. So this is least soluble, C6H5 NH2, and the second one will be this one, C2H5 twice NH, and the most soluble will be this compound with less carbon chain, NH2. Okay, then the fourth question says arrange in increasing order of basicity in aqueous state. So you need to focus on the word aqueous state here. So whenever a compound is in the aqueous state, you need to consider 3 factors which affects the basicity of amine compounds. The 3 factors are the plus I effect, steric hindrance, and the solvation effect. So considering all this, the sequence of basicity will vary. And here they have given ethyl groups as the substituent on the nitrogen. So in the case of ethyl groups, we have already studied the sequence is secondary, followed by tertiary, and then followed by the primary amines. Secondary will have the highest basicity and primary amines will have the lowest basicity. So by write down the sequence for this, you have to start with the lowest basic compound. In this case, ammonia will be the lowest basic, NH3, followed by the primary amine, C2H5, NH2, and then you will have your tertiary amine C2H5 thrice N, and the highest basic compound is the secondary amine, so C2H5 twice NH. This is in the case of amine containing ethyl groups. Now, if instead of ethyl groups they have given methyl groups, then the sequence will be secondary followed by the primary followed by the tertiary. Secondary will have the highest basicity and the tertiary will have the lowest basicity. So this is about the arranging basicity in aqueous state. Okay, then the next question says complete the following acid-base reactions and name the products. So we already know that whenever an acid reacts with a base, it leads to the formation of salt. Now in this case, your amine compound is the base and HCl is the acid. So this two will react and leads and forms a salt. Now this nitrogen with the lone pair of electron, it will use its lone pair of electrons in forming bonds with this hydrogen atom, and it forms CH3, CH2, CH2, NH3, and N will have a positive charge, and then Cl minus. Now it also says name the product. So the name of the product is 1, 2, 3 carbon atom. 3 carbon atom stands for propane. So in this case it is propyl. So this is N-propyl ammonium chloride. Okay. Now in the second one, you have a triethylamine, or you can see that N-diethylethanamine. When it reacts with HCl, it will form C2H5 thrice, and again it will lose its lone pair of electrons in forming bonds with hydrogen. Therefore, N plus HCl minus. Now the name of this compound will be triethyl ammonium chloride. Okay. Now the next question is, write the chemical reactions of aniline with benzoyl chloride. We know the structure for aniline. Now you must know the structure of benzoyl chloride in order to carry out the reactions. So the structure for aniline is, you have a benzene with NH2. Now when this reacts with benzoyl chloride refers to benzene with C double bond O Cl. This is called as benzoyl chloride. We have already done this. Now this nitrogen with the lone pair of electron has to come and attack this carbon atom. For that, the pi electron will shift. O will have a negative charge, C will have a positive charge. Now on this positive charge, your N with the lone pair of electrons will come and attack. And this will give rise to N, hydrogen, and then connect this N with this carbon. So therefore C, and O will have a negative charge, and then the chlorine atom, and then the benzene ring. Okay, now what happens is N has used up its lone pair of electrons, therefore N will have a positive charge, and this negative charge will come back and sit in the form of bond, and this chlorine will leave because it's a very good leaving group. And from this, in order to stabilize the positive charge on the nitrogen atom, hydrogen will leave in the form of H plus, and this will form your benzene ring, this one, and then NH, and then you have your C double bond O, and then this benzene ring. So you have to name this compound as well. Now the name of this compound is this is called as phenyl. So N-phenyl benzamide, benzene with C double bond O is called as benzamide. The name of this compound will be N-phenyl benzamide. Mite refers to the amide group, C double bond O. So N-phenyl benzamide, you have a benzene which is next to C double bond O, therefore benzamide. So N-phenyl benzamide is formed when you react aniline with benzoyl chloride. Remember the structure of benzoyl chloride, that is benzene with C double bond O and then one Cl atom. Okay, then the next question says convert benzene to aniline and also 1,4-dichlorobutane to hexane 1,6-diamine. So for this, you are going to recall the preparation of amines, which we have already done. We have done 6 methods. Now we are going to use those methods in getting the correct answer. Now the first step is you need to know the structure of the reactant and the structure of the product that you are trying to get. So I'm going to do the first one, that is benzene to aniline. Now the first one, the reactant is benzene and the product that you are supposed to get is aniline, benzene to aniline, NH2. Now you cannot just introduce NH2 on the benzene directly. First you have to think about converting benzene to a intermediate which can be converted to then the product. Okay, so in this case, think about converting benzene to nitrobenzene. So nitrobenzene is obtained when you treat it with concentrated HNO3 and concentrated H2SO4, which acts as a nitrating agent. This gives NO2 plus, which gets introduced on the benzene ring, and you get a nitrobenzene. Now nitro group can be reduced to NH2 by treating it with a reducing agent, that is under reduction of nitro compounds, which we have already learned. You can carry out reduction of nitro compounds by 2 methods. The first one is chemical method, which is metal plus HCl, and the second one is addition of hydrogen in the presence of nickel. So let's say I'll take metal plus HCl. And what happens is this NO2 gets converted to NH2. This nitro group is reduced to NH2. So that's how you convert any benzene to aniline. The second one is convert Cl, CH2 4 times, that is CH2, 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 and then Cl. That is 1, 2, 3, 4. You have chlorine on the first and you have chlorine on the fourth carbon atom. So this is 1,4-dichlorobutane. And you have to convert this to hexane 1,6-diamine. If I write down the structure for hexane 1,6-diamine, hexanes refers to 6 carbon atom. 1, 2, 3, 4, 5, 6, and you have amine, diamine. You have NH2 group on the first and the 6th carbon. So NH2 on the first and then NH2 on the 6th carbon. And fill all the remaining bonds with hydrogen atom, because each carbon always carry 4 bonds. Now you have to convert 1,4-dichlorobutane to hexane 1,6-diamine. Okay, now see, the reactant has 4 carbon atoms, whereas in the case of product there are 6 carbon atoms. So you need to have 2 more carbon atoms in the product. So for that we will use, under preparation, we are going to use the method reduction of nitriles. Under reduction of nitriles you get amine containing more number of carbon atoms. So for that, first you have to think about converting Cl to nitrile groups, and you are going to treat it with Cl, CH2, I'll just write it in this way, 4 times Cl. When you treat it with sodium nitrile, NaCN, you are going to get both the Cl will be substituted by the Cn, and you will get Cn, CH2 4 times, and Cn. Now you have got Cn group on both the sides. Now this can be reduced. You can use reduction of nitrile compounds by treating it with hydrogen in the presence of nickel, and you convert Cn to CH2 NH2, which we have already done. So this gets converted to NH2 CH2, and then you have your CH2 4 times already, and then this gets converted to CH2 NH2. This is your hexane 1,6-diamine. So that's how you convert a less carbon atom to a more carbon atom compound, by first converting the chlorine atoms to the nitrile groups. Once you get the nitrile groups, you can carry out reduction of nitriles with the help of hydrogen in the presence of nickel as the catalyst, and you get your product containing 2 more carbon atoms. So that's about this conversion.